Welcome everybody. Today we'll introduce you to another family of the organic chemistry, which are the esters. So first of all, the general formula of esters, actually it's composed of alkyl group and then you have carbonyl group and followed by oxygen and then alkyl group. Let's take a beautiful example. You have a methyl group in here, which is an alkyl, and it's followed by carbonyl and then oxygen and then CH3, as we can see. We can represent the ester in this way, or in this way, like as a structural formula. We can write COO in the middle, or you can abbreviate the two O's into O2 in here. But the question now, how can we synthesize an ester? So the reaction that we synthesize ester by is called esterification, or it's another name, a condensation reaction. And once we say condensation, it means that we are grouping together molecules and then end up with one molecule. So this is actually what happens here. You should have the carboxylic acid first and then alcohol. You mix them together. The condition here, you should use a concentrated sulfuric acid, and it should be concentrated, put in your mind. And then you will have ester and water molecule. But what is the role of sulfuric acid? By the way, sulfuric acid works as a catalyst. It's not a reagent. It's just like a catalyst. And we can remember that the catalyst can provide an alternative pathway for the mechanism of reaction, makes it with lower activation energy, like the story. And don't forget the water molecule. So first of all, you have a carboxylic acid, CH3, COOH. It's called ethanoic acid, and alcohol. And we can see that it's composed of 3 carbons, 1, 2, 3, and here for the acid it's 2 carbons. First of all, you have to write the carboxylic acid like CH3, C double bond O, and then O. Put in your mind the H here is removed, okay, and the whole group of alcohol, except the OH, will replace the hydrogen. By the way, it's not the real mechanism for this reaction, but in order to understand what will be the structure of the ester. And so far, there is a mechanism for making an ester, and it's not included so far in the A levels, and that's why I'm not gonna explain it so far. So this oxygen in here will be bonded to the group in here of the alcohol to here. It's connected to oxygen in the area of the OH. So you will start with CH2 and then CH2 and then CH3. So now your ester is ready, and not to forget the water molecule, because like the mechanism of condensation of this reaction actually produces water. What do we call this ester in here? How can we name the ester? First of all, we have to put in our mind, this is the alcohol part, okay, and this is the carboxylic acid part. And the naming of esters, we start naming the alcohol first and then followed by the carboxylic acid. Okay, so what we to do? I like to make like a cross in here. So we start with alcohol. How many carbon we have? We have 1, 2, 3, then it's prop. But we call an esters like a propyl, alkyl, methyl, ethyl, etc. So it's a propyl. And what about the carboxylic acid? It's composed of 2 carbons only, and that's why it's called ethanoate. So this is the name of ester that we have. And now let's just think about this molecule. I added concentrated sulfuric acid, SO4. So from this reagent, we can deduce that it works as an esterification process or the condensation. But we used to find like 2 molecules, like separated molecules, like carboxylic acid and alcohol. In this case, we have only 1 molecule. So what to do in this case? Put in your mind, as long as we have a carboxylic group, like C double bond OH, in addition to hydroxyl group, then we can make esterification. So the first step in here is numbering the atoms that we have. So you have 1, 2, 3, 4, 5, 6. How can we make an esterification reaction? As we said, This compound or this molecule contains the functional group of carboxylic acid in addition to the functional group of hydroxyl or alcohol, which means that we can make esterification or condensation reaction. So what we have, what should we do? Just like think about the circle or the cyclic ring that you'll have as a result of the OH of the carboxylic acid that will replace or it will bond to the carbon of the OH group. Okay, so just imagine that you made a circle. What will be the product? So first of all, you have to think, you have a ring of 5 carbons. You have 1, 2, 3, 4, 5. So I will start from number 1, which is the double bond, and then this is carbon number 1 and the double bond in here, okay? And now let's go to carbon number 2 and 3 and 4 and 5, and then what? This carbonyl group in here is bonded to the OH, which means that we have to make an oxygen, and then we connect it to this one in here. So if you start recounting the number of atoms again, I mean the carbons, we have 1, 2, 3, 4, 5. And we just remember that the carbon number 5 here is bonded to the oxygen in here. All right, and just don't forget something. We have a carbon or methyl group that is in the 5th carbon, so we have to do it in this form in here. So this is the product, and not to forget water molecule in here. Okay, and now let's go to the opposite of ester. If I want to break down the ester, what do we call the reaction? The reaction actually is called hydrolysis, and generally hydrolysis, it could be in any molecule other than ester. So the hydrolysis process itself means breaking down the molecule by water. So today we're going to break down the ester by 2 methods. You can use either. So the first method of hydrolysis of ester is using a dilute acid in the presence of heat. Or you can do the hydrolysis process of ester by a dilute alkaline in addition or in presence of heat. So let's take an example of this beautiful ester in here. We can notice that this ester is propyl ethanoate. And if I want to make hydrolysis for this ester by dilute acid in the presence of heat, what will be the product? So I just want to write it again in order to understand the process. CH3, C double bond OO. And then CH2, CH2, CH3. So you just remember that the ester is composed of alcoholic part and addition to the carboxylic part. This is the alcoholic part and this is the carboxylic acid. I just want to write it carboxylic acid and this is alcohol. So if you add an acid in the presence of heat, the part of alcohol will change directly to the alcohol. It becomes like CH3 and then CH2 and then CH2 and then OH. We put the OH in the side of connecting with oxygen. And for this guy here, it just like goes back again to be the carboxylic acid, which is ethanoic acid. All right, so these are the products. This is the alcohol, which is a propanol, and this is the ethanoic acid. And now if I want to make the same process but using dilute alkaline solution, I mean, I could use sodium hydroxide diluted. So what should I do? If I want to make sodium hydroxide NaOH, what will happen? First of all, we just remember that it's composed of CH3, C double bond, this is the carboxylic acid. But at that point, we do not write an acid. This is the difference between doing the hydrolysis by acid or base. So since we're adding alkaline solution in addition to heat, and it should be diluted, by the way, it should be diluted, don't forget, then it gives you this is positive. We call this ethanoate, okay, or sodium ethanoate, okay, in addition to the alcohol part, which is the same as in the acidic way. So we have CH2, CH2, and then CH2, and here we have OH. And if we need to make like to change the sodium ethanoate into acid, we do a process of acidification, which means adding an acid in it. So if we add an acid to this compound, it will immediately change to carboxylic acid and it gives you this guy in here. Okay, so this is the process of making hydrolysis of ester using alkaline or acidic solutions. There should be diluted, don't forget this.